Look up at the night sky, what do you see? You see stars. Billions of them. Those are just the ones in our own galaxy. The Milky Way. Beyond our galaxy there are billions of other galaxies, each one filled with billions of stars. The numbers are staggering. In the face of such immensity, a profound question arises. It's a question humans have asked for millennia in different ways and cultures. Are we alone? Is this small blue-green world the only place life has taken root? Is consciousness, the ability to ponder, a singular event in space and time? The universe is about 13.8 billion years old. Our solar system is a relative newcomer, at about 4.5 billion years old. Life on Earth has been around for at least 3.5 billion years. This is a very long time. It gives the cosmos plenty of opportunities for life to arise elsewhere. Think about all those other stars. Many of them are like our sun. Many of them have planets orbiting them. We call these exoplanets. We've found thousands already. Some are in the habitable zone. Water is a key ingredient for life as we know it. Where we find liquid water on Earth, we find life. The building blocks are everywhere. So how do we search for our cosmic neighbors? We can't just hop in a spaceship and travel to the nearest star. The distances are too vast. Our fastest spacecraft would take tens of thousands of years to reach even Proxima Centauri. Instead, we have to be clever. We have to listen. We listen for signals. This is the core idea behind SETI, the search for extraterrestrial intelligence. The universe is filled with natural radio waves emitted by stars, galaxies, pulsars. But an intelligent civilization might use radio waves for communication just like we do. A signal from another technology would look different from cosmic noise, narrowband spikes, patterns on a spectrogram. We use massive radio telescopes, giant dishes scanning the sky. These are like giant ears pointed at the sky. They can detect incredibly faint radio signals from billions of light years away. Telescopes like the former Arecibo Observatory and FAST in China. They listen across a wide range of radio frequencies, waterfall spectrums, frequency bands. Scientists are particularly interested in a quiet part of the radio spectrum called the water hole. Between the hydrogen and hydroxyl lines, a natural cosmic hailing channel. Some scientists reason an intelligent species might choose this frequency as a cosmic hailing channel. The search is not just passive listening. We also look for techno-signatures, unusual light curves, megastructures, industrial pollutants, spectral fingerprints. Powerful telescopes like JWST analyze exoplanet light for chemical fingerprints. The challenge is immense, a needle in a galactic haystack. How many civilizations might be out there for us to find? It seems like an impossible question to answer. But in 1961, Frank Drake came up with a way to think about it. He created an equation. The Drake equation doesn't give a definitive answer. It organizes our ignorance. It breaks the big question into smaller, manageable questions. The equation has several terms. Rate of star formation in our galaxy. How many of those stars have planets? How many planets sit in the habitable zone? Fraction of those planets where life arises. Fraction where intelligence evolves. Fraction that develop detectable technology and how long they remain detectable. Multiply all these fractions and you get NN equals detectable civilizations in the Milky Way. In Drake's time, many terms were unknown. Science has filled some blanks. Kepler showed planets are common. Most stars seem to have planets. Many are small, rocky worlds. The first few terms look optimistic. The later terms remain mysteries. We don't know how often life starts, or how often intelligence follows. N can be 1, or millions. The Drake equation reflects our hopes and fears. The Drake equation suggests our galaxy could be teeming with intelligent life. Even with conservative estimates, there could be thousands of civilizations out there. Many of them would be far older and more advanced than we are. So this leads to a simple, yet powerful question. It was famously asked by Enrico Fermi during a lunch conversation in 1950. If the galaxy is so full of aliens, he wondered, where is everybody? This is the heart of the Fermi paradox. It is the stark contradiction between the high probability of extraterrestrial life and the complete lack of any evidence for it. Think about it. Our galaxy is about 100,000 light-years across. That is a vast distance, but the galaxy is also very old. If a civilization arose a few million years before us, that's a huge head start. Even with modest technology, a civilization could colonize the whole galaxy in cosmic time. Self-replicating probes could spread and become unmistakable. In a few million years, their presence would be obvious. Yet, when we look out into space, we see nothing. No probes, no signals, no giant constructions. We see only silence. It's sometimes called the Great Silence. Why haven't we heard from anyone? Why haven't we been visited? There are many possible solutions, hopeful ones and terrifying ones. The silence transforms the sky into a profound mystery. One potential solution to the Fermi paradox is both fascinating and unnerving. It is called the zoo hypothesis. This theory suggests advanced civilizations exist and they know we are here. They are watching us. We are like animals in a zoo. But they've deliberately chosen not to make contact. Instead, they may have set Earth aside as a cosmic preserve, or a laboratory. Observed, studied, not interfered with. We're observed and studied, while keepers follow a hands-off policy. They follow a strict hands-off policy. This would explain the Great Silence. They are silent because they choose to be. It is a plausible reasoning from an advanced perspective. An immensely advanced civilization might have a code of ethics. They might see us as a young, developing species. History shows when advanced societies met less advanced ones, results often were catastrophic. A wise civilization might avoid repeating that mistake on a cosmic scale. They could be protecting us from the disruptive shock of contact. This idea echoes the prime directive from science fiction. But would every civilization agree for millions of years? Wouldn't a rebel break the rules? We can't prove or disprove it. Despite objections, the zoo hypothesis remains a compelling if unprovable explanation for the eerie silence. Another solution to the Fermi paradox is much more ominous. It is called the Great Filter. The theory proposes a barrier on the evolutionary path from chemistry to galaxy-spanning civilization. There is at least one step that is incredibly improbable, a barrier that almost no species can pass. A filter so difficult to overcome it explains why we see no one else. The universe might be full of life, but something prevents it from becoming technological on a grand scale. The chilling question, where is the filter in our own timeline? There are two main possibilities with vastly different implications. One suggests the filter is behind us. Good news. Maybe the leap from chemistry to the first self-replicating life was the filter, or the jump from simple to complex cells. If so, we are rare and have a clear shot at a cosmic future. We might be one of the very few. We could still expand and thrive, or the filter is ahead of us. Far more terrifying. Life and intelligence might be common, but something happens at a technological stage. A technological challenge, AI risk, devastating weaponry, or environmental collapse could stop civilizations. If the filter is ahead, the silence is a warning. The empty sky could be a graveyard of civilizations. The Great Filter turns the search into a high-stakes gamble with our future. Science fiction has long been a tool for exploring ideas about alien life. Writers grappled with the ethics of contact before scientists did. The Prime Directive, a fictional non-interference rule, expresses humility. It forbids interfering with the development of less advanced cultures, because even well-meaning contact can shatter cultures. Instead of asking where the aliens are, maybe we should ask, should we try to contact them? Projects like MEDI intentionally send messages to nearby stars, but is broadcasting wise? Our shouting might read as immaturity. We might be provoking danger unknowingly. Some respected scientists have voiced serious concerns about MEDI. They argue we should listen, SETI, not transmit. Better to be cautious than broadcast our coordinates to unknown forces. We know nothing about what kind of life might be out there. What if they're not friendly? What if they're predatory? Broadcasting our location could be an existential risk. The SETI versus MEDI debate echoes the Prime Directive dilemma. It forces us to consider our responsibilities as a species and potential galactic citizens. Our first contact could be our last if we're not careful. We must weigh curiosity against caution. When we search for life, we tend to look for life that is like us. We look for planets with liquid water, atmospheres with oxygen, carbon-based chemistry. Carbon is amazing. It forms long, complex chains like DNA and proteins. But is this the only way? Are we suffering from carbon chauvinism? One candidate is silicon, abundant and able to form 4 bonds. But silicon chemistry is less versatile. Its dioxide is a solid, making waste expulsion harder. In exotic conditions, silicon life might thrive, crystalline forms on hot worlds. What if life doesn't need a star at all? A civilization could exist in interstellar cold, powered by decay or stored energy. Perhaps they are energy beings, plasma held by magnetic fields, or uploaded minds in machines. Or minds uploaded into machines, living in virtual reality, needing only energy. Such civilizations would be nearly invisible to our astronomy. They would require abundance of energy, not planets the way we think. These ideas stretch the boundaries of life and highlight our blind spots. They are speculative but useful. The universe won't conform to our expectations. We might be looking right at alien intelligence and not recognize it. Its signals might look like background noise to us. Its physical form might be stranger than we identify as alive. The universe is a very big place, and it's had a very long time to experiment. The possibilities are endless. We must keep our minds open. The first alien we meet might not be a little green man. It may force us to redefine life. Why do we do it? Why spend time, effort, and money searching for life? We point giant telescopes and send robotic explorers because we dream and we wonder. The search for extraterrestrial intelligence is about more than finding aliens. It is a deeply human endeavor connected to who we are and what our purpose is. It is a quest for context. Finding life, even simple microbes on another world, would be a scientific and philosophical revolution. It would tell us biology is a fundamental property of the universe. We would not be a unique miracle confined to Earth. Conversely, if we find only silence after centuries of searching, that is equally profound. If we are truly alone, it places immense responsibility on our shoulders. All the consciousness, art, music, love, and wonder in the universe could reside on this fragile planet. We would be the sole custodians of the universe's ability to know itself. The pressure to survive and protect this flicker of awareness would be immense. We would need to act as guardians. This is why we look. The search holds up a mirror to humanity. It forces us to confront our future potential and limits. It asks us what we will pass on to future generations. Whether we find company or confirm solitude, the journey changes us. The search expands our horizons and can unite us as one species. The quest connects us to the universe, and in doing so, helps us understand what it means to be human. The journey is the destination. We look outward and inward at the same time. We search because it helps us become better stewards of our world. Whether we find company or not, the quest inspires cooperation. The universe is vast. Our curiosity endures. If you enjoyed this journey, subscribe and join the search. Until next time, keep looking up.